Hi there, it's Ron Gula from Gula Tech Adventures, and today we're going to talk about cybersecurity and AI. Now, a lot of times I get a lot of questions asked as an investor, do you want to look at my company that's got artificial intelligence and solving some sort of cybersecurity problem? And a lot of times I'm like, maybe, maybe not. It's not that unique. There's a lot of that out there today. Now, to give you some context, I got some other videos here that we've talked about in the past where we talk about different types of nomenclature when it comes to incident response, cyber products, threat intelligence, that sort of things. But now, when you have a cyber product, it comes included with artificial intelligence. And that can mean a lot of different things to a lot of different people. And I kind of break it down like this. Most cybersecurity products do some sort of alert. Maybe it alerts, maybe it stops, maybe it blocks a network session, stops a DNS lookup, stops a process from executing. But there's a process, and whether it's preventing or alerting, it's still running an algorithm. Most of the time, it's blocking or detecting because it's got a known signature, right? A hash, an IP address, a DNS name, some sort of indication, a sequence of steps that says it's a bad thing. Or it's doing some sort of anomaly, right? This is the first time I've seen a user log on from this area here. Ron Gula's logging on from Thailand. I'm not in Thailand. I'm in Maryland. That sort of thing. But then when we add AI to this, we now have based on an AI training, right? Where we take some sort of database of things and we come up with a model where we can then predict these other two things. Now, it's all the same. Whether or not I have an amazing amount of threat intelligence, I'm just blocking on that, or I somehow train an AI and all that threat intelligence and do that, it still involves a block and an alert. So just keep that in mind when you're thinking about an AI. Now, the biggest thing with an AI, though, is that you have to train it. And typically a human is going to do the training of the AI that's out there. And you're going to show these AI algorithms all sorts of different things to teach them what is good, what is bad, and what they should do. Now, there's a couple strategic issues with this when you think about putting AI into a product that's making cybersecurity decisions. So the first thing is is it lab data or is it live data? Now, if, I've got a vendor and they are constantly, scouring the internet, their partners and maybe threat intelligence, they're constantly feeding new examples of bad into a model and training that model. That's great. But then you have this problem of the 0-day customer where, if I do the first time I run a vulnerability exploit on a customer for the first time, it's a 0-day, nobody's seen that before. And maybe in the lab, you've seen those things. Maybe they haven't. A classic example is malware, right? If I get a bunch of malware from VirusTotal and I train my AI recognizer to look for that malware, that's great. Well, that just assumes that all new malware is going to look like the stuff on VirusTotal. So, it's really important to have these feedback loops and have these constant updates. The kind of thing you want to ask any type of cybersecurity vendor who's feeding that their system. How much are they keeping it updated? How much are they doing? How much is your live data, going to train these new models? And another thing you want to consider is what is the schema. Now, when I got into network intrusion detection back in the mid to late 90s, you were looking at packets, you were reassembling TCP sessions, you were looking for patterns of malware and stuff. And at the time, being able to detect a no-op buffer overflow in the late 90s was like a novel thing. Nobody had done it at that point. And today that's a pretty common practice. However, you didn't have an AI system to tell you that was kind of a unique thing. Now, maybe a better example is that when I look at most outputs from most AI systems, I can probably go to a Splunk query and do the same query, right? There's usually a frequency analysis thing. There's usually some sort of statistical thing. There's nothing magical about the fact that we recognized a first-time seen event, that a spike in traffic compared to old traffic. What's hard is trying to understand when it's relevant. And a lot of times these AI models for different cyber applications are actually doing more summarization and telling us maybe the top 3 or 4 things that are unique on that list. That's not necessarily always a bad thing. So, being able to describe what goes into the AI model when you train it is a really, really interesting thing. Take like DNS filter, for example, right? So they're really, really good. One of our portfolio companies, they have an AI model to classify new DNS domains as either good or bad. They have a false positive page, just like any good type of AI system, back system does. But I never get false positives with it. So their algorithm's really, really, really good. The question is what goes into that? That becomes really, really proprietary, and it becomes a really hard thing that you want to tell your customers what you're doing or what you're not doing. So trying to understand what's in that schema is a really difficult thing, and it's important to know like how hard would this be able to do without AI. Now, another thing you want to look at in that schema is, do you have causation or causality, right? The classic examples, I have an umbrella. When it's raining, therefore, the umbrellas are causing it to rain, right? A lot of times these models for when you're training AI can really, really give you the wrong sort of indication, right? I've got malware on port 80, therefore all port 80 traffic is malware. That's not really true, right? I've got malware coming from an IP address, therefore all traffic from that IP address is malware. Again, those things are pretty basic that you can get wrong even with basic threat intelligence. But when it comes to these AI models, it can be just as hard. Now, another thing to keep in mind is that the attackers, the nation states, and the defenders are going to keep changing their tactics. Now, I got the spy versus spy image here, and that kind of shows that there's always an attack and a counterattack, right? There's a punch and a counterpunch. There's maybe an attack, a vulnerability, and then mitigations that go into that. So the question I always have for AI vendors is what happens in a world where your models that you trained are in environments where nobody's doing them. I've tested some systems in the AI pen testing place, and they were tuned 100% for Active Directories. Now, again, most of corporate America in the world runs Active Directory. I don't run that here, so it really didn't do anything on that. But it also didn't advertise that that's exactly what it did either in that training. So it's a really interesting problem to understand, what are those things designed to do, and what are they designed to exploit? And then can they be mitigated with just a simple change in changing how you're running your computers, your mesh networks, your zero trust networks, and whatnot. Now, another thing that's kind of interesting is that when you train an AI system, I see this more on the logging side of things, where I'll have customers, tell us, hey, they're looking at a certain startup vendor. It does anomaly detection through logs. My first few questions, okay, what kind of log sources are you doing? Like a lot of these AI systems say they're going to do natural language processing, but then I say, okay, do they speak Fortinet logs? Do they speak NetFlow? Do they speak, JSON output from some vendor that you've never heard of? And a lot of times it's like, no, we still have an integration process. We've got to bring it in. And to me, I'm basically saying that's SIM 3.0 or whatever is going to come after next gen SIM. Because if you can't, clean the data and sanitize the data, then you can't, train these AIs on this kind of stuff. And a lot of organizations I talk to really do say that, even if they're like a Microsoft, 100% Microsoft shop, the way they're configured, the way they're collecting their logs, what they're sending to Sentinel might be a little bit different than how another customer does it, let alone if you want to throw in CrowdStrike or different web proxies or startup vendors that you haven't got to market yet. You end up having this Tower of Babel problem where the AIs don't know what they're looking at. And, the fact that they're not alerting gives you a false sense of security. Now, I know this is a little bit more being negative on AI. I'm just saying these are the realities of dealing with these AI. The reality is that right now in 2023, if you have a human team and you're working with AI systems, you're a bionic man. You are a bionic woman. You are going to be able to perform better than somebody who doesn't have these tools. Now, what this means yet for security operations centers, what does it mean for incident responders? What does it mean for compliance auditors? I don't think the market's really seen that yet. We've seen a lot of AIs for detection and prevention. And there's been some, really good uses of that, but I haven't really seen, the loss of, I don't need 35 people in my 24/7 SOC because I've replaced them with AI. I'm seeing people who are performing better. They can triage events better. I'm seeing a lot of that kind of stuff. So I'm seeing that AI is more of this future of a symbiotic there. So having said that, if you're evaluating AI products, I hope this was useful. If you want to see more videos like this, please subscribe to us here at the Gula Tech Adventures YouTube channel, or come sig us out over at gula.tech and follow us on LinkedIn. I'm Ron Gula. Have fun bringing AI into your cybersecurity program.